Hi everyone, my name is Mohammed Sidki. I'm the AIA Mateo County Chapter President. I want to welcome you all to our third Committee on the Environment event for the year. Today we are very excited to have Justin Schultz, PE, Principal and Regional MEP Practice Leader at Borough Happold, Larry Strain, FAIA, Funding Principal, Siegel and Strain Architects, and Sean Armstrong, Managing Principal at Redwood Energy, for a discussion on carbon neutral buildings and sustainability. Before we start, I'd like to make a few chapter announcements. First, we want to say thank you to our chapter sponsors, our Platinum chapter sponsor, Leah and Braze Engineering, our Gold chapter sponsors, Romig Engineers and MN Builders, and our Silver chapter sponsors, Da Vinci Marble and BKG Structural Engineers. Upcoming events, so on December 16, that's next Thursday, we'll have our last ARE 5.0 study session for the year with our guest speaker, Joy-Chi Chin, architect at DES Architects and Engineers, and session topic is door hardware. On January 26, we'll have how architects and interior designers can work collaboratively with our guest speaker, Linda Sullivan, principal at SDS. Okay, today's session format. So Kenny Hung, our Committee on the Environment Chair, will start with introduction to COTS and to today's event. 6:10 to 6:40, we'll have 3 case studies presented by our speakers. 6:40 to 6:55, we'll have a panel discussion for 15 minutes, followed by another 15 minutes of open Q&A. Please mute yourself to reduce background noise. Feel free to add your questions in the chat box during the presentation. So you don't have to wait all the way to the end. Just put in the chat box, and if any of the speakers can look at it, they may give you the answer right away. Or we can just read your question in the end. And note that this session is being recorded, and we are going to post this session to our YouTube channel. So if you just go to YouTube, AIA Mateo County, you'll be able to find all our previous recordings for COT and all other AIA Mateo County events for the year. With that, I will give it to our chair, Kenny Hung. Kenny?
Hi, everyone. Just excited to see everyone here attending the event this evening. Like Mohammed said, this is the third event of the year about our carbon neutral building and community design series. You know, one thing I hope everybody's following the Global Climate Summit, COP26, and whether we are happy with the result or the progress, that's your opinion. But I think one thing we have learned though is it takes a team of experts. We need to work together to make this happen, to achieve the carbon neutral growth. And that's what we are doing tonight. We invite a team of experts who have spent their time, really passionate and have energy on carbon neutral building projects and sustainability projects. And so we're really, really excited to have this event. And, you know, they're going to talk about 3 exemplary examples of carbon neutral buildings, you know, talking about whether it's a new building, new ground-up buildings, or, you know, building reuse or large scale residential projects. And, you know, looking at from energy perspective, carbon emission, or from a community perspective, what does it mean for carbon, you know, carbon neutral projects? So, that's very exciting. We have a lot to share, and after the case study, we're going to have a panel discussion about some of the you know, topics and the really relevant to the carbon neutral building design. You know, with that, I'm going to introduce our first speaker of the evening, Larry Strain. Larry is, like Mohammed said, is a founding principal of Siegel and Strain Architects based in Emeryville, California. The firm is known for community projects and innovative sustainable design and research. Larry, you know, has served on the board of Northern California chapter of USGBC, the Ecological Building Network, the Carbon Leadership Forum, and he was on the research team for the Embodied Carbon Benchmarking Project. Larry is a prolific writer and has been speaking on materials, carbon, reusing building for more than 20 years. For the last 10 years, he has been really focusing on the total carbon footprint of the built environment. Without further ado, let's welcome our first speaker of the night, Larry Strain.
Okay, thank you very much, Kenny. Good evening. It's nice to be here. Thank you for having me. In a minute, I'm going to show you a case study that illustrates what I'm going to be talking about, which is why existing buildings are one of the main ways to get to carbon neutrality in the built environment. We have to keep in mind that existing buildings emit 28% of global emissions. Building new buildings is another 11%. So if we can avoid building so many new buildings, just hang on, buildings, and retrofit the ones we already have, we've got a good chance of reducing both sources of emissions. We're still going to need new buildings, but we really need to focus on saving and upgrading what we have already. So a few quick definitions. Embodied carbon is the carbon footprint of a material. So greenhouse gas emissions from extraction, processing, transportation. There's a huge hit of carbon at the beginning of a building's life, but it also includes emissions from maintenance and repairs, which happen over time. So it also includes construction assemblies, not just the materials themselves. Next slide. Operational carbon are all the emissions from operating a building. And they include the direct emissions from heating, from burning fossil fuels on site to heat a building, but they also include indirect emissions, which are burning fossil fuels to create electricity typically. So those happen off site, but they still are the responsibility of that building. And these emissions are ongoing and accumulate over time. Next slide. Avoided carbon are greenhouse gas emissions avoided by making one choice over another. So an example is rehabilitating an existing building compared to demolishing it and building a new structure, or an upgrading an existing building compared to leaving it alone. So those are different versions of how one choice over another results in lower carbon, avoided carbon. Next slide. So I'm going to show you a renovation project. This is by Sarah Architects, and it includes an embodied carbon analysis. It actually included a total carbon analysis, both embodied and operational carbon, which is why it's such an important study. These slides are from a presentation that Sarah gave to the AIA Historic Resources Committee, and they were kind enough to share their presentation with me. Next slide. It's a large federal office building, about 500,000 square feet in Portland, Oregon. Had a large integrated design team as well. Sarah were the architects of record, and they worked with James Cutler Associates, the design architect, and had an excellent engineering team and a construction management team as well. They had about a $141 million budget to renovate this large office building. Next slide. It needed a lot of work. They needed to upgrade all building systems. They needed a seismic upgrade on the existing buildings, which is typically a big embodied carbon hit. They needed to update the work environment and get better lighting, improve indoor air quality, and they needed to improve accessibility throughout the building. So they had a lot of things to do to this building. Next slide. The existing building on the left there was constructed in 1974. The demolition included removing all those precast concrete panels from the outside of the building, and then constructing a new skin or a shade structure. You'll see how this works on different sides of the building. And they got a lot out of doing that. And I'll show you in a second what they got from that. Hang on a second, next one. So they are also able, by getting rid of those precast panels and building the new skin outside that, they were able to actually increase the rentable, leasable area of the building. So they actually got an extra 28,000 square feet of building on all the floors. And that was about $235,000 to $300,000 of annual revenue earned, because it's on a square foot basis. So they got some benefit by removing that skin. Next slide. And the other thing that was really interesting is that by removing all those precast concrete panels, they lightened the building enough so that they didn't need the structural upgrade. So they avoided a huge piece of embodied carbon that they would have needed to strengthen this cast concrete structure by removing all that extra weight, because it was based on current seismic codes, and they lightened the building enough where they did very minimal seismic upgrades. And they built this new skin, which served multiple purposes, but it was also much lighter than those precast panels. Next slide. The facade was optimized for each orientation, and was optimized both for what they needed it to do. So on the west side, which is where the big heat gain comes from, they had that undulating aluminum reeds that covered the facade and reduced heat gain by about 50%. The north side, they did no shading. They just did a simple wall with glazing. The east and south sides, they did horizontal and vertical shades, but much simpler than the west side. So they did this both to figure out what they needed on each side and then to keep the cost down. If they'd done that undulating facade across all four sides, it would have cost a lot more. So they were very smart about the way they upgraded the building. Next slide. So they did this shading strategy. As I said, they reduced about 50% of the shading on that west facade. The south and east facades were simpler. You can see them on that picture on the left. And they reduced the heat gain in the building, which minimized the energy needed for cooling. And I'll show you what that did for the building. It got extra benefit from that. Next slide. What it allowed them to do was they reduced the heat load enough so that they could go to a radiant cooling panels on the ceilings. You can see that without the external shades, the heat is so hot that wouldn't have worked. The cooling capacity of the radiant panels would have been exceeded. When they reduced the heat load with the external shades to that solid blue line, then they were able to use this much more efficient system and save energy on that as well. Next slide. They also did a lot of performance upgrades on the building envelope. They have a fairly low glazing to wall ratio, 40% glazing, low infiltration rate. They really tightened up the building. They have good daylighting. They added light shelves and things like that to bounce light into the building, and just really improved the performance of the building, and also made a much nicer interior, as you can see on some of those slides on the left. Next slide. What they got from this, the existing building had an EUI between 77 and 83. I don't know why there's a range there, but I guess the way they measured it. The average for that kind of building is 94 EUI. And their target was 34 to 36 EUI. They were going to basically cut their EUI in half. And you can see this compared to some other high performance buildings that have been built in the last 10, 15 years. And it's right in there with all of those. Next slide. When they actually did the building, they got an EUI even lower. The actual measured EUI of the building is 31.5 kBTUs per square foot per year. So they exceeded their goals. And they got about 61% savings in energy use just from the mechanical and envelope upgrades. Next slide. They also did a detailed embodied carbon analysis, and then they put this all together. They used Tally to model the building, and the way they had to model it, most of you are probably familiar with Tally, but it basically uses the material quantities that are modeled in your Revit model to calculate the environmental impact of those materials. Next slide. And what they did was they did the as-built. They modeled all of the work they did on the building, and then they designed a new replacement building to have a base case to compare it to. It's what it would take, what the carbon footprint would have been for a new building. And you can see that they're identical, except that the new floor-to-floor height would have been higher on a new replacement building, because that's the way they're building that kind of building today. This has a fairly low floor-to-floor height, the existing building, which makes daylighting more difficult, but they were able to keep it. Next slide. The new replacement building would have generated about 15,000 tons of CO2 to build, and the as-built building was a little under 7,000 tons. So it's less than half. And you can see that most of that savings was in the product. In other words, the transportation, the maintenance, the ongoing, the end of life aren't that different, but they were able to, the product was different because they reused most of the structure in the foundation. So that's where all the savings was in all that reuse. And it's 53% of embodied carbon was avoided. Next slide. That 8,000 tons of savings is about almost 2 large-scale wind turbines running for a full year, or about 1 million gallons of gasoline in embodied carbon savings. Next slide. Now, the first thing, when I saw this building, first time I saw this when it won an AIA Code Award, I said, well, that's great, but how much did they spend on that aluminum curtain wall? The embodied carbon must have been staggering. And they had the same thought. So they went back and actually modeled the savings that the curtain wall generated versus the embodied carbon it took to build it. And you can see that the light blue bar across the bottom is the standard curtain wall embodied carbon. The as-built embodied carbon of that curtain wall raised it by about 10 tons of emissions. And the savings happened, the savings actually in four months, the savings overtook the actual added embodied carbon. So they saved that amount of embodied carbon in 4 months of the better performance of the curtain wall. So that was pretty impressive, I thought. Next slide. And this is what it looks like all put together. So if you look at, I'll try and walk you through this diagram. The bottom blue bar is the as-built remodeled building. So it's about 7,000 tons of CO2. The hatched bar above would have been a new building. So that's the embodied carbon of that. And then the different sloped lines are the 3 different scenarios. So the yellow line is the existing building as it was. If you just left it alone, didn't do anything, that's that yellow sloped line. That's the operational performance of that existing building. The new building is the green line, or the remodeled building is the green line, basically overtook the existing building, just doing nothing. All the embodied carbon invested and everything by 2019. So in about 6 years, it overtook that building. From then on, it does significantly better. And the red line is what the performance was of a 2-code building for a new replacement building. And it doesn't overtake the existing building until 2030, roughly. And you can see that the difference between the remodel and the new building or the existing building, maybe alone, is about 13,000 tons saved over that period of time. So it really makes sense. If we're going to get to carbon neutrality, we're going to have to do it with existing buildings, because we just can't afford to keep building new buildings. Even if they're close to net zero, it still takes a while to recover the amount of energy the amount of carbon it takes to build a new building. So this is just an illustration of a well thought out project that both saved embodied carbon by avoiding building a new building, and saved a lot of operating carbon by really increasing the performance of the building. So I think that may be my last slide, is that right? Okay, I've got a couple more. So how do we do this? You put together a really committed integrated design team. So they had a very good team that really worked together and worked back and forth between embodied and operational carbon. Set ambitious energy upgrade and emission reduction goals. A lot of remodels and upgrades that we do to buildings have targets like, well, let's improve energy performance by 20% or maybe 30%. We should have the same energy goals for an existing building retrofit that we do for a new building. And in this case, where we should all be, the goal should all be net zero at this point. We don't really have time for anything else. And you want to look for strategies that can save both operating and embodied carbon. So the sunscreens were a great example of that in this project. They saved operating carbon by avoiding a lot of heat gain, and they saved embodied carbon because they avoided a seismic upgrade. So there was a double whammy. So you need to look for those opportunities when you're doing a building like that. And finally, we really want strategies that save carbon now, not 20 years from now. So I think that's the end of my slide. We can't really save the above if we don't save the bottom. So thanks.
Great. Thank you, everyone. Next up is Justin Schultz. He's a professional engineer with Buro Happold. They have offices across the globe. They're an international firm that uses they are integrated consulting engineers and advisors. Justin's a principal and regional MEP practice leader at Buro Happold. And his passion in science and technology, Justin's expertise spans globally across a range of sectors that also includes high-rise commercial, higher education, flagship retail, cultural museum, historic rehabilitation, government projects. He's going to be giving us a presentation about City Hall project in Santa Monica.
Good evening, everyone. Hey, thanks, Ross, for the intro, and thanks to the San Mateo AIA Committee on the Environment for inviting me today. As Ross mentioned, I'm Justin Schultz with Buro Happold. Recently joined Buro Happold in our San Francisco office, and I'm really excited to share with you a case study on the Santa Monica City Services building that we just recently completed. Next slide. City Hall East was designed and constructed to meet the world's most rigorous criteria for sustainability, resiliency, and long-term cost effectiveness. And it was a model of green design aimed at efficient operation, healthy and productive workplace, and providing positive contributions to Santa Monica. Next slide. As a living building, the new facility will produce all of the energy and water it consumes on site. And this really marks a shift away from buildings that use less to ones that are really regenerative. So it's a model for fiscal and environmental sustainability in the future. Utility costs are going to be saved over the life of the building, and it will never have water or electric bills. And here's some quick facts, and I'm going to dive into these a little bit further as we go through the presentation. Next slide. So just a little bit of background, the public service functions of the City of Santa Monica had really long outgrown the original City Hall building, which is in that green circle in the middle. It was a nearly century-old historic structure located in the heart of the city. And as the administrative functions grew over the decades, departments were housed in spaces in other parts of the city. And really by the mid-2000s, these spaces were in 5 or 6 separate locations when discussions began about consolidating them back at the city center at City Hall. Next slide. So you can see here, connected to the south wing, the building fulfills really this vision to bring all core municipal operations onto one campus and create a centralized hub for public counter services. So where we as architects and engineers go for planning and to review mechanical plans, electrical plans, what have you. So building will reduce municipal costs over time by consolidating all of their assets. And it meets cutting edge criteria for what's called the Living Building Challenge, all supporting Santa Monica's commitment to sustainability with goals for carbon neutrality, water self-sufficiency, and zero waste in the coming decades. So really, in addition to creating more energy and water than it uses, the City Hall campus hosts gardens in its courtyard and grounds for farming edible crops. You can see here on the site plan here. So they have all edible crops here, and that really supports the local biodiversity. They've selected plants to be native and adaptive, just to be eaten and picked and harvested locally and consumed kind of locally in Santa Monica. So with these and other features, the project will advance Santa Monica's sustainability standards and really set international records as the first municipal structure with a Living Building Challenge certification. Next slide. So honestly, I didn't know too much about the Living Building Challenge until recently, but to meet the Living Building Challenge criteria, the city services building must be healthy and beautiful, surpassing even the highest LEED certification requirements, and must offer regenerative spaces that connect occupants to light, air, food, nature, and community. The new structure must be self-sufficient and remain within the water resource limits on the site, produce more energy than it uses, and it also collects and treats all the water on site, ultimately creating a positive impact on the human and natural systems that interact around it. So the standard really ensures that the city services building will make positive contributions to the environment as opposed to merely lessening the negative impact. Next slide. So really what the city was asking, can they afford this? And I think what they came to is, can we afford not to do this? When you take a step back, this building is going to be owned and operated by the city of Santa Monica for its lifetime. It's going to provide a community asset. It's future focused. When we did the life cycle cost analysis, all of the measures that we've implemented will pay for itself within 15 years. It meets the city's climate action goals and really sets a new design standard and defines the procurement strategies for future buildings in the city of Santa Monica's portfolio. Next slide. For the purposes of this discussion, the Living Building Challenge had a panel of 7 kind of, the ethos is like 7 major items. We're going to touch on a few of them today. Kind of the most important starting with net zero water. Next slide. There were 3 separate water strategies that collectively allow the building's needs to be met. And so we're harvesting water on site. For potable water uses, rainwater is captured on the roof. It's also captured from all the PV panels, and it's brought to a 40,000 gallon cistern located beneath the building. In drought conditions, it's supplemented by groundwater pumped from a well on site. All the rainwater in the groundwater is treated with a combination of filters and active carbon filters on site. For non-potable water uses, system captures gray water, as well as all the condensate from mechanical systems and treated via a bioreactor and used for on-site irrigation. Next slide. Can you go back one? Sorry. Yeah, you can go for one. The last bit of the water use is all of the projected sewer demand from the building was cut by half with the introduction of a composting system for all the labs. So just to break this chart down here, on the left-hand side was kind of the baseline case, and the brown bar at the bottom was all the laboratory use. So you can see here the chart on the right off the bat, we're eliminating all the black water from the site by using composting toilets. In addition, by collecting all the rainwater and collecting it in a cistern, we're able to offset the amount of rainwater that is that falls kind of in the winter months, you can see on the left, and then offset that over the entire course of the year to basically achieve net zero water. Next slide. This is just another quick overview of the water system as a whole. You can see water is collected from the roof. It's all fed into a system where it's treated on site, and that's serving all of our laboratories, our showers, what have you. And then all the gray water is again treated on site where it's then used for irrigation. Next slide. And this is just a picture of the composting system located in the basement of the structure. It requires some maintenance. It was approved by LADPH as a pilot program. It's kind of the first of its kind in this area. And so this is just it, but all of this space planning was a part of the design and just one of the considerations that we had to consider as part of the project. Next slide. And again, this is the gray water treatment, or this is all the gray water treatment that is done on site. So again, just a lot of mechanical services that were required as part of this project that may not have typically been considered as part of a standard building. Next slide. The next major component from the Living Building Challenge portal that I really wanted to touch on is the materials, health, and well-being. Next slide. And the project was designed to provide healthy air to the occupants by focusing on limiting source pollution, providing best practices ventilation rates that will be enforced via operational strategies. So we're implementing environmental sensors, and as well as continuing what LEED already builds upon, which is no smoking policies and extensive entryway systems cleaning, which are kind of things that we've grown to do on most projects already. Next slide. Some of the adaptive feedback that we've provided to the occupants is we're actually monitoring contaminants, and all of this provides feedback to the occupants, but it also is integrated into the building management system and can operate it can operate windows and change the ventilation system in the building. And next slide. In terms of materials on the project, there really has been a wave of activism over the years on the larger social impact of green building materials and new research into the life cycle performance of those materials. It's really no longer enough for a building to be net zero, solar powered, or utilize non-potable water. Like really, we're really diving into the raw materials and products used to construct green buildings. And those materials have to be sustainable from both an environmental and a social perspective. So next slide. This is the Living Building Challenge what they call the red list. And these are essentially all the banned things that we could not have as part of the project. And it's really an extensive list. The design team began vetting materials really early on in the schematic design and budgeting phases, and we were able to develop a work plan with the team to divide it up and vet materials across the board to start developing the performance specs on the project. The project was ultimately a design build delivery. So after 50% DD, we handed off the project to design build contractors, and having this plan in place up front really allowed the subcontractors to take this and do the research on the appropriate manufacturers in the bid process. But it was really, really important for us as a design team, architects, engineers, the owner, really to be focused on the specification, like really, really upfront in the project, which, as we all know as architects and engineers, the specs sometimes take a backseat until later on in the process. Next slide. And really just to put the red list in context, eliminating carcinogens, asthmagens, et cetera, from building materials can significantly improve the air we breathe. Next slide. So breaking this down into something that I deal with all the time as a mechanical engineer, just ductwork. What we don't even realize is all the things in a typical duct system that are specified and we might not typically analyze. But in the Living Building Challenge, we had to analyze every bit of an assembly, including sealers, mastic, foil, protective coatings, duct closures, adhesives, whatnot. So it really just goes to show, like, every system, whether it's a lighting component, you know, each lighting fixture and all the little bits and pieces that are in a lighting fixture, it felt like a daunting task as we were starting down this road, cataloging every bit and material to make sure that it conforms to Living Building Challenge guidelines. Next slide. The last component from the Living Building Challenge that I want to touch on today is the passive design HVAC strategy. Next slide. So we implemented a number of passive design techniques to maximize daylight views and natural ventilation to ensure occupant comfort, but also minimize energy use. The buildings also, based on the design, the building is hardened against natural disasters and will serve as an essential public safety service center in the event of an emergency. And you'll see why in a little bit. But based on the energy modeling done during the design phase, it was clear there was not enough roof area to accommodate solar to take care of all the electrical loads alone. So we were able to implement, luckily, there's multiple other PV solar arrays on site that was needed for net zero energy performance. Next slide. The architectural form of the building really helped us with the daylighting strategies. The building itself is very long and narrow, and the width of the building is only about 50 feet wide. And really that helped us with the daylighting strategies by pushing all of the workspace to the perimeter. And similar with natural ventilation, it just really allowed us to use the geometry of the building to cut down our energy use, whether it be electric lighting or ventilation. Next slide. I'm going to spend a minute on this slide because it really tells the story of kind of all the systems. But large operable windows are located at 2 levels on each floor. One at occupant level, and then they're meant to be manual windows that someone can just walk up to and open. But then there's a second level that are automated, and those are up high, and those are controlled by the building management system based on outdoor conditions. So nothing needs to be done. You know, if the building is, you know, in COVID times when the building is not heavily occupied, you don't need someone to go and manually open windows to implement these strategies. So the building kind of lives on its own and automatically opens windows when it's optimal. What else? You can see on here, we've actually implemented phase change material on the walls and on the ceilings. And this really allows the building to retain heat or retain heat in the winter, or retain the cool energy in the summertime. So really just, it added thermal mass to the building. And that really allowed us to utilize the conditions of, Santa Monica at nighttime. We're getting the air right off the ocean. We're able to cool down the building at night and then really retain that heat, or retain that those cool temperatures during the day with minimal mechanical HVAC systems. We do have a backup VAV system purely just for backup, but it's not meant to be the primary source of heating or cooling. Next slide. And again, so it's just some of the passive design strategies. In addition to all the mechanical strategies, one of the goals was, how do we reduce the electrical load? Well, one, it's reducing our lighting power densities. It's in practice with the equipment that they're issuing to all the folks that live here. Everyone, instead of desktop computers, everyone was issued laptops, and they cut down on the amount of printers and monitors and things like that. So looking at the plug loads in the building was also really important in analyzing kind of the overall electrical use of the building. Going out of the norm with cooling strategies. Because we're using natural ventilation, we were able to kind of adjust the expectation of the mechanical system and say, well, look, a typical office building may be cooled to 74, 75 degrees. Well, we're actually going to raise the set point to 78 degrees, but look at the thermal comfort, and based on placement of occupants up against windows and how the ventilation is operating, prove that that higher temperature is going to be okay. Well, that also has a return because it reduces the amount of air that needs to be heated or cooled. So that has a energy savings associated with that. Next slide. In addition, like I said, we're implementing phase change. We have hot water and chilled water running through all the slabs of the building. So we're utilizing the structure of the building to provide additional thermal mass, whether it's in heating mode or in cooling mode, to heat and cool the building. And it is a concrete slab structure, which yes, does have some embodied carbon to it, but we're using that thermal mass of the building to reduce the mechanical equipment capacities of the building. Next slide. And this just encapsulates the overall energy efficiency savings from kind of a baseline code compliant building to our proposed living building challenge net zero energy building. And our energy conservation measures are kind of down on the bottom here. Optimizing lighting, utilizing natural ventilation with night flush, focused on an improved envelope, and exposed thermal comfort mass. And next slide. And just in closing, you can flip to. Just in closing, the Living Building Challenge consists of an ambitious, really ambitious set of goals, which can require an unusual set of building strategies and systems, contributes to, honestly, budget risk and schedule risks that many clients may be apprehensive about taking on. It really takes the right client at the right place to implement a building like this. City of Santa Monica really was the best client, one of the best clients to approach with a building like this. They already had the ethos that they came to us wanting to implement a building like this, really setting a foot forward for the future. They're going to hold on to this building for the lifetime of the building. So it makes sense because they can pencil out a 15-year payback on all the energy conservation measures, because they're going to hold this building for 50 to 100 years. I think that is it on mine.
Awesome. Thank you, Justin.
Yeah.
So next up, our third presentation is Sean Armstrong from Redwood Energy in Arcata, California. They also work remotely. Redwood Energy focuses on zero net energy for multifamily housing. Together with his clients, Sean has developed cost containment strategies to make net zero energy a reality, profitable, reducing the cost of HVAC, domestic hot water, and the solar budgets by 30 to 60%. And he's going to provide a case study for a project in Spring Lake.
Hello, hey everybody. So can I get the next slide, please? Okay, I'm going to lead you through a cute little case study. This is a multifamily case study in multifamily excellence. It's called Mutual Housing at Spring Lake. It's a suburb of Woodland. It's phases 1 and 2. It was stridently opposed by the neighbors, so the development was unwelcomed, and it was for farm worker families. And it's beautiful. It's won the United Nations Grand Prize Award. Next slide, please. I'm going to talk about all the cool stuff that it's done. So it got to the DOE Zero Energy Ready Homes Program and LEED Platinum and Greenpoint Rated Platinum, Enterprise Green Communities, WaterSense, Energy Star, Indoor Air Plus. It won 2 awards from the Department of Energy for innovation, won the Grand Prize from the United Nations World Habitat Award, and just got awarded the 2021 Clean Energy Hall of Fame awardee, Mutual Housing California developer for this project. So next slide. What's the big deal? Well, the United Nations awarded it in part because we had succeeded in showing how it was cost effective to do a zero net energy building. So from the left to the right, it cost $2,549 more per apartment to build to the standard of zero energy ready. Not the solar array, all the efficiency. Then the solar array cost $6,555 after the incentives. That was the cost per apartment. That's cost. The post-rebate cost of the apartments and the solar array, so after the incentives, the rebates, all that stuff, the actual project cost is $9,104 per apartment to be 100% solar powered, all electric, solar powered, super duper efficient. And then we have the permanent loan increase because utility bills drop from $125 to $203 per apartment to $10. That it becomes rental revenue. That's income to the developer, which is the whole point. Hey, Danuta. So you have as a total project benefit at the end of the day, over the course of just 15 years, the project continues to exist and the solar arrays are warranted for 25 years, as are the inverters. So this is just the first 15-year capture. In the first 15 years, it made a total of $501,000. So that is the net, 501. So the benefit was 856, the cost was 355,000. The net benefit is 501, which is $12,851 an apartment of net benefit, or $500,000 for the whole development. Next slide. So who's there? It's a farm worker family community. It's a lovely place. No, next slide. Who owns the community? The community. Mutual Housing California is an organization that it's a nonprofit, and its bylaws specify that the majority of the members of the board be current, past, or future residents of the apartment complex. Next slide. Who was landscaping for? I was really touched by the edible landscaping you're just showing, and this is another one of those examples. It's peach trees, avocado trees. The landscaping is also rolled gravel. So this is angular gravel, about 4 inches of it, heavily rolled, so you can ride a bicycle or a tricycle, etc., over the landscaping open area, but it still lets water in. So we haven't made any issues with like the water draining into the storm drains, etc. It just goes right through the gravel. It's permeable, but it's a playable space, and we roll it right up to the trees to essentially protect them. We put a couple wood pieces around them and such. And so this is something Mutual Housing California has done in other developments. The picture on the right is from a nearby development in Sacramento, and those are jujubes, delicious, called mountain apples. They're back when people could still smoke cigars in movie theaters, and the whole place is filled with smoke. They would eat jujubes, the original fruit, because it's mucilaginous and would soothe your throat while you're in the smoky movie theater. And now they became candies, but they're not actually jujubes, they're just sugar candy. But that tray of jujubes, those are the real ones. Next slide. Where does the gray water go? The Aqua Loop. This is the only certified for above ground irrigation treatment system that there is. So we've collected all the gray water from the showers and the laundry room, and we send it through this treatment facility. It's lots of different things. Like it's multiple filters, it's a UV sterilizer, etc. Settling tanks. And you can see the before and after, and that water is now safe for kids to get sprayed with. It's NSF 350 certified, so it's safe for above ground, like people could touch it. It's clean. It's been cleaned and sterilized. Next slide. So the kids, they grow up safe and free from poverty. These are people, farm workers are making $12,000 to $18,000 a year as a household. With kids, 1 to 6, I think that was the most I ever saw, but most, like 2, 3 kids per household, sometimes 4. And so here's a couple little quotes. Quote, this is a parent. I was always scared when the bill would come when it was either really hot or really cold. In total, for the 5 months that we've been living here, the bill has come out to under $30 total. Next one over there is that the day we moved in, my 7-year-old son ran inside the house yelling, I love my house, I love my house. So here you see that's the woman who's presenting up there, she grew up in farm worker housing. She was the project manager. That's how mutual housing rolls. So Vanessa there, like she used to have a can of rocks and she'd throw them at the rats. And her brother is a city council member of City of Sacramento. So both of these siblings have really come up in society. Mutual housing has her as the lead developer, project manager. And they're there showing people about how to do integrated pest management and what's going on here in the landscape and what things are safe to eat. And this is people being good to each other. Next slide. So the tenants and the owners both benefit from the energy efficiency. Energy Star appliances. I want to mention that the hood is Energy Star. That's nice because it means it's quiet. Most hoods are super loud. In apartments, usually you have like a 3 to 7 sewn hood. This is a 1 sewn hood. So you can actually use it the whole time you're cooking without getting a headache. And then we invented these things. These little canary instruments is another reason why I got a bunch of awards. And these are tenant education meters. One side goes green to red over the course of the day as you use up your daily energy budget. The other side flashes at you as a green use that you're doing right now. It's a red use or a yellow or a pinkish mauve. Or it went to purple if you ran out of energy budget, just let you know. But it was a pretty color. Not a mean color. It's just like, hey, that's how it rolls. You ran out of energy for your budget today. So everyone had those in their kitchen to help them, interpret their apartment. Next slide. Was the efficiency worth it? I showed earlier, absolutely. It built 1.3 apartments. And here's just some fun examples, like them putting all the goop around the electrical outlets. Justin, to your point, there was not enough attention paid, even with all of those certifications, to being thorough everywhere. Like I would love to get to do a Living Building Challenge building. I covet that. But so far, only LEED Platinum. So anyway, and then this cool little shower head, it's got a thermostatic valve. And this was important for getting the solar array small enough to be afforded for phase 1. Phase 2 solar prices had dropped radically. Phase 1 is 2012, 2013 pricing on solar versus 2018. And we're talking like half as expensive, a third as expensive now. It's a whole different world on solar today. So anyway, these shower heads, you take a 6-minute shower on average in the United States, but you spend 1 minute more before running hot water and 1 minute before that running cold water. So it's 2 minutes cold water running and then another minute of hot water before you actually get into a 6-minute long shower. That's how the average shower works. I've done the studies myself. This is true. People spend a whole minute undressing once they see the water's hot. Then they spend a minute getting out of their clothes and in. So this thing, when the water gets hot, it shuts off the shower. Brilliant. So it's just a little tab. You get in and the water's hot. But you can like walk around the house and take your sweet time getting in the shower. Next slide. Which phase had better HVAC and domestic hot water? Totally phase 2. Everyone likes to think that phase 1, which has a combined system, so it's 1 heat pump producing hot water for that tank, and it's got this controls, lots of valves in there, and it sends hot water to a fan coil for the furnace, like the ducted air, pardon me, and then as a tank of hot water for the water use. This was expensive. It's no longer offered, unfortunately. It's totally for sale over in Europe, where everyone does hydronics. The United States is a limited number of people that could sell to. It's sensitive to problems. It's a huge system. It's 3 tons. Water heating is only like a 4,000 BT, 1/3 ton job, and they're using a 3-ton heat pump to heat the water, which is like in spring and fall in these super insulated buildings. There's no air conditioning or space heating going on for months. People are only turning on their air conditioning and space heating system between 1 in 3 and 1 in 6 days out of the whole year. Think about 1 in 6 days. That's how much they're using the heat pumps. So we have this 3-ton heat pump for a tiny little water heating need. On the right-hand side, we have a right-sized water heater. It's a 50-gallon tank or an 80-gallon tank. Everything's really carefully plumbed to skinny little pipes, 3/8 pipes, so people get their water hot, fresh. And then there's the heat pump on the right there. Just want to point out, that is not a VRF. That is a ductless mini split with multiple heads coming off of it. Totally different. Looks similar? Not. The important difference is that this is inexpensive and easy to install. A VRF, that takes refrigerant and it goes to a manifold box where it gets arrested and it has to be repumped out of it, and there's leak potentials all the way along. And so you might have $22,000 in an apartment for a VRF HVAC system, and this is $12,000. A big difference. So this is a mini split with multiple fan coils coming off it. That's how I recommend people do all their work. You can run the pipes as long as 250 feet, and you can get them as big as 5-6 tons. So there's just, use this way of dividing up the refrigerant and sending it off as one of the things we learned as we're doing bids and such. Next slide. Okay, and this last slide, say basically Spring Lake was 3% paid for by Green Building. Out of its total budget, that was the net profit. It was about 3% of the budget. And that built 1.3 of the 40 apartments. And it was to everyone's mutual benefit. It was really a sweet project to be involved with. So there you go.
Well, thank you. Wow, it's really great to see all this exciting project. And thank you, Larry, Justin, and Sean, sharing the design strategy and some of the particular design challenges. So I know the audience would have a lot of questions for you guys. And but before that, we have a couple questions for the panelists tonight. And let's start with Larry. Earlier in the conversation, we can talk about you're part of the Carbon Leadership Forum group, and you've been the Carbon Benchmarking Committee, research projects. And I know you've been working on some tool to look at, and compare, carbon emission for, existing building reuse and compare with new building. Do you want to share some of the ideas over there?
Yes, for about 2 years, I've been developing a tool which is going to probably be out in the spring, which basically allows you to compare an existing building versus retrofitting that building and remodeling it some versus building a new building. And it just gives you the total carbon outputs of each of those scenarios. So based on how big your retrofit is, or how much you're remodeling it, or what kind of new building you're putting out, it will give you a comparison of those 3 options. So it basically gives planners, mostly planners, it's not really a design tool, it's an estimating tool. So it's fairly broad brush. It uses benchmarks to do it. It doesn't use actual data, it uses benchmarks for different things. But it gives you a pretty good sense of, and typically what you'll see is if you're not doing major structural upgrades, the existing building retrofit and upgrade will always be the winner. Unless you're doing major structural work to an existing building, or unless you really can't get the energy performance out of an existing building upgrades always save the most carbon. I mean, the only way you can beat it is if you have a net zero new building and your existing building only gets maybe a 30% improvement or a 50% improvement. Because what we're really interested in is big improvements over the next 10 years. That's really what we're facing. So the new building will always beat the existing building if it's really efficient in 20, 30, 40 years. We don't have that much time. So the idea is to look for strategies that get you the biggest savings, the quickest, and this tool will help planners and building owners do that.
Mm-hmm. Great.
So feel free to share your screen, Larry, if you wanted to show that program.
Okay, I can, let's see, let me get it up on my desktop. I can just show you a quick, what it looks like. Hang on a second. I don't see my screen. under the share. Let me, this, Firefox, inbox?
So there should be a share screen in green, basically in the middle. And
Yeah,
you
no,
need to hit escape first.
I see that, but I just, when I go to share screen, okay,
Oh.
here we go. All right, I didn't have it open. So this is what the tool, this is what the dashboard looks like.
Okay.
And you basically enter basic building data about where it is and what size it is. And that will give you your climate zone and a bunch of other things about your building when you enter this data. Then you enter data about the upgrade. So you can click over whether the mechanical system's new or partial. You can look at the envelope, whether you're doing minor or major. You can look at all these different upgrade pieces, how much you're upgrading. And it spits out an embodied carbon number for that. And then you set your performance target. So the default for the existing building, it's CBEX based on CBEX. So 85 kBTU is this building type. And the performance target for this building was 80% better. So it gives you that. And then you do the same thing for the new building. You can look at 4 different building types. Each one has a different embodied carbon footprint. This mid-rise is basically a commercial steel and concrete frame building. And you can see that if you'd picked a light wood frame building, it drops to half that. So it gives you different carbon footprints. You pick your performance target for the new building. You've got some embodied carbon modifiers at the bottom, and it plots it out. So there's the existing building on the left. That's all operational carbon because you're not doing any upgrades. The retrofit shows you your operational carbon in yellow and your embodied carbon in blue. And the new building shows your embodied carbon and your operational carbon. So, and then you can see it over time, you know, the existing building, just the retrofit overtakes the existing building in about 3 years in this case. The new building would overtake it in about 9 years, but you're always going to be lower carbon with the existing building retrofit is always going to be lower than both other options on this one, this particular example. So that's how it works in a nutshell, and we're hopefully, this is an Excel version. We're getting it built right now in, so it'll be an open source web-based tool probably early next year.
Wow, that sounds great. Thank you, Larry. I mean, looking forward to using this tool for our projects. So another question, you know, I know Stephen has another question, and we'll follow with that in a minute. So another question is, I think Sean kind of touched on, is about the cost, you know, benefit to the communities, the residents, and cost is always a big issue when we talk to our client about doing more for sustainability, and in this case, carbon neutral buildings. You know, Larry, Justin, and Sean, just want to see what your thoughts is, and how do you usually approach client with this topic? You know, what kind of tools or presentation you talk to them to convince them to do more, to commit to sustainability?
Yeah, I'll start really quick. It's funny, so particularly in MEP systems and switching to all electric heating, for example, there's this perception that all electric buildings are significantly more expensive. And I think in the beginning, and I say the beginning, I mean, Europe has been doing this for a very long time, and it's really, you know, in California, and particularly in the last 2 years where it's become commonplace, it's really about education and educating our clients, educating each other as well. But now that we have a number of these projects that have gone through some stages of design and have gone through some stages of budgeting, what we're finding is there really isn't a huge delta to implement some net zero strategy, or not net zero, but just electrification strategies, for example. Net zero is a completely other discussion, you know, going full net zero or doing a living building challenge building. But to meet the new codes and just go all electric, those systems are actually, we're finding, you know, are marginally more expensive, you know, 5% more expensive to implement those on the mechanical side.
Mm-hmm.
So it's really about education, because it's not as big of a hit as people think it is.
I'll chip on that one. So I agree with education. I work with clients. So I start off in rural areas, and I still do a lot of projects where you'd have to extend natural gas quite a ways to get into a project site.
Yeah.
Or in the cities where it's crazy expensive because you have to shut down a street, you know, to cut into it and then deliver gas. And so seeing that each building is somewhere between 15,000, these are all bids, 15,000 per building to add natural gas to it, to $100,000 for extending natural gas. And then there's the plumbing through the building. And then you actually get to the device, all of which have electricity. All gas burning devices have electricity delivered. So you already did the infrastructure for that. You're just adding more. And it delays things. And it's always the most tense day on a job site when you're hooking up the gas, because you have a flammable kaboom kind of moment. And people do die in construction sites. You can search it on the news. People die building buildings with gas. So just go through a list of cost savings. And then it's mechanical systems. You know, central heat pump water heaters are where it can be more expensive, but on HVAC, it's generally less expensive. The appliances, you know, an electric stove is a little bit cheaper than a gas stove, but from the same manufacturer, same model, same everything. It's about $100 cheaper on both the laundry dryer and the stove for same, other than just gas and electric. So it's either cost neutral or maybe a little bit of a cost savings, definitely a time savings. And then, as you saw, you can do the electrification and efficiency work. You put in the solar array, and if you can grab the revenue from the solar array, it pays for itself in 4 to 8 years. You have the project for however number of years. You know, affordable housing is 55 years of affordability, and you cannot walk away from that job for 15 years. You can't sell it. It's yours, period. So like that first 15 years, it doesn't make sense for you to have a cost, you know, put in that solar array. Mm-hmm. Absolutely. So I flip clients. That's sort of like my goal in life is to flip the clients from gas and to electric. And I'm just like, it saves money, it's safer, it's easier, saves some time, don't have to coordinate with the utilities, just go through this list of problems. And then if I really am frustrated, sometimes I'll remind them, and it's the American South that is building 4 out of 10 homes in the United States, and they build about 80% all electric now. So we're just a bunch of silly Californians out here doing the California dream. Like real builders build all electric.
Larry, any thoughts about this? Or?
We should probably move on, but the only thing I would add is that my argument is that 90% of the time, retrofitting a building costs less than building a new one, period. I mean, you know, it's
absolutely.
Contractors don't like it. It's complicated, but it's generally cheaper. So I think you can make that argument. The only argument it's harder to make is if they can get increased value by tearing a building down and building a bigger building. That's what the developers are interested in. So that's a harder one to counter, and I think that's going to take policy support to handle that.
Great. One question here, probably just for Justin. You know, you have worked on a lot of life science projects. It seems like that's the elephant in the room that we haven't addressed. You know, in California, more than 49 cities last time I checked have adopted REACH code, but many of them make exception to life science building. So what do you see from an MEP engineering perspective? Is technology going to catch up? How do you see the trend is going?
Well, it's interesting because a lot of the work that we were doing together is down in South San Francisco, but there are other municipalities that do not have exceptions. I mean, San Francisco being one, Berkeley being another, and so we know that we can build an all-electric lab. And I just toured one. I was in London in our London office last week, and just toured one at Imperial College London, 12-story high-rise lab building, all electric, and they've been doing this for years. On the other, it's not, you know, these heat pumps, they're not new technology. Really, we know that we can do an all-electric lab, and really it's education. How do we reduce the energy of the lab? You know, end users have they're kind of ingrained in how they want their lab set up, particularly in like the number of air changes. Those numbers have historically been very high, and so labs historically waste a lot of air. So getting the air change levels down, very important, and being able to have a smaller all-electric plant. Similar on the exhaust side, codes are changing. We used to have constant volume exhaust to maintain a velocity to keep, get those contaminated particles, as high as possible. Title 24 actually requires that lab exhaust systems have some sort of monitoring, have wind monitoring, I'll even take it a step further, and we've been implementing chemical monitoring. And so those systems that can now react to the contaminants. And so if it's completely diluted and the system doesn't sense anything, those systems can turn down for a good portion. I mean, I would say 80% of the time, it'll be turned down to a minimum versus wasting 100% of the energy. And so the key is, how do we reduce the amount of energy that's in these that the labs are using? Then it makes it easier to implement an all-electric strategy, but it can be done. And so it's just getting developers on board. It's a lot easier on the institutional side. Like, I've seen it, higher education, at UCSF, at Berkeley, it's a lot easier to sell it because they're going to own those buildings for, they'll do a 100-year lease or something like that on those buildings. But developers, they may or may not hold on to a building. So anything that has a life cycle payback, it's typically developers, it doesn't matter to them if they can't roll that into the lease with their tenants. So
great. Well, at 7:10, I think probably it's a lot of great ideas here. Maybe Ross, we can start with the Q&A section here. See if our audience have any question for us panelists tonight.
So the chat box actually has been on fire, and I know that Sean has been responding to so many people.
Being friendly.
Let's just open it up to the audience. Let's take like a couple questions. I know that Steve, you had 2 questions. I think the first one was for Larry. Basically, Steve was asking what was the contribution of the on-site solar to the overall carbon reduction in the building? So Larry, the building you are presenting, Steve is asking of basically the solar panel. What was the on-site solar contribution to the carbon reduction in the building?
That's a very good question. I don't have the actual number, so I don't know the answer to that. It did factor in. I think that the big point I'm making with this is that the solar and going net zero with this scale building is probably very difficult to do, the size of the building. And really we should be looking at sort of what your existing building is putting out there in terms of loads and emissions, and how can you get that as low as possible? Because we sort of have to, it's more important that we tackle all the buildings we have and make significant improvements than we get a few more net zero buildings. So I guess it's not really, I don't have an answer to your question about the contribution, but I think that there was a really good book by Charles Ely a few years back that basically said that almost every climate zone in the US, if you have a 3-story building with a flat roof, you can go net zero. If you go above 3 stories, it gets harder to do. But up to 3 stories, it's possible in every climate zone except parts of Alaska. So there you go.
And there are now like 9 and 12-story tall zero net energy buildings. I'm working on an 11-story one. There's one that's going up right now that's in Seattle that's 12 stories. You have to put solar on the wall.
Right.
You have to put it the west side, the south side, the east side. You have to put it up high if you've got shading coming at it. But people are doing it.
Yep.
Mohammed, can you hear me?
Yes.
Yeah. Really, the more important part of that question that I asked was, if carbon neutrality is the goal, and again, Larry, everything you said, it was a great presentation. Everything you said was extremely important. Existing buildings are the big problem, and we've got to do more. But if carbon neutrality is the goal, then really the stake we need to plant in the ground is not simply carbon reduction. Because at the end of the day, embodied carbon is still carbon. And so really what we need to do is pay back the carbon debt. Net zero energy is about eliminating operational carbon. It never was about eliminating embodied carbon. But now we really need to be focused on net positive and paying back the carbon debt of the embodied carbon if we're going to call it carbon neutral. And I really think we need to start being a little more honest about this carbon neutral goal and acknowledging that that's really the stake in the ground, not net zero, you know, not net zero carbon, but carbon neutral. And I'm curious about your thoughts on that.
Well, I agree with you, but I think that if you can, I think we have to get big reductions on our way to carbon neutrality. And I think that significant upgrades to existing buildings and avoiding building new buildings. So you're avoiding two sources of carbon there. You're cutting your carbon, embodied carbon, at least in half generally. And it's because we're not going to, you know, if you're going with net zero buildings that are brand new, it's going to be even harder to make those pay back because it's twice as much carbon you're trying to pay back. So that's really the goal. The other thing I would say is that I think that we really have to move towards and assume that decarbonizing the grid is the goal, not PVs on every single building, because PVs have a pretty high embodied carbon footprint as well. So I know they're going to be somewhere. They're going to be either on your building or somewhere else. But I think the point is centralized PVs may be the way to go. It also is a much more equitable solution because it's basically you're saying that if the whole grid's decarbonized, everybody gets this decarbonized energy, where if it's PVs on your roof, only some people can afford that. So it's another approach that I'm not as big a proponent of putting photovoltaics on every single building as I used to be, I guess, for those reasons.
I have lots more to say, but I'll take it offline with Larry.
Okay, I have a question from Susie to Justin. She's asking what inspired the city of Santa Monica to go for a living building challenge?
It was really their ethos. They are going to own they're going to own and operate this building for the lifetime of the building. And it was, given the size of the building, it's not a terribly large building, but they knew that they could implement this strategy and pay it back within a relative, I mean, 15 years to me seems like a pretty short, short payback considering they're going to own it forever. So it's really just encapsulated in their ethos to implement these strategies and then kind of move that forward in other buildings that they build in the future.
Okay, and I think we'll take one more question to Larry. It's from Danita. She's asking, have you had any opportunities to do building retrofits that make significant improvements in California?
We've done some. Another case study that I show frequently is the DPR net zero office remodel in San Francisco. And the thing that's great about that, it's a much smaller project. It's only 20,000 square feet. But that one achieved net positive performance and significantly reduced embodied carbon. And what was when I first did that study on that project, we thought the embodied carbon savings were going to be the big story, and it turns out that the embodied carbon savings of avoiding a new building was about 650 tons of carbon, and the carbon saved over the life of the building by going net positive was 5,000 tons over a 20-year period. So it's going back to Steve's point, it is really important that the performance of these remodel buildings has to be net zero or net positive even. We have to hold existing buildings to the same standards we're holding new construction. And we got to figure out how to do it, because it's not like, well, it's harder, so I'm just going to go 30%, improvement. We've got to have the same goal, exactly the same goal. And it's harder because the codes don't support it. The codes support, you can put a code in place for a new building net zero. We don't have codes yet in place that make existing building upgrades mandatory. And I think we're going to have to face that at some point. I don't know how it's going to happen, but I don't really see getting where we need to get to if we're ignoring 28% of the world's emissions, which are all existing buildings. It's not going to happen.
I wanted to add on that one. The experience I've had, I just work in affordable housing. So we've been electrifying affordable housing since 2015 because the developers are making money off the solar array benefits of the electrified loads. And these are communities where this is a win-win, less air pollution, lower utility bills. The rent gets collected. It's a higher rent when the utility bills go down. So it's neutral, but you have a house now that's resilient with solar power. And your bills are going down because you invest in energy efficiency, because that was also cheaper than getting a larger solar array. And I found it's a really strong business model that actually works across the affordable housing industry, that if the owner can solve the split incentive of investing into a rental but not getting the benefit back out. And there's lots of split incentives out there of like, I'm not going to own this building after I build it for 1 year. And so that's a split incentive of the current versus the future, or the owner versus the tenants, that kind of situation. If you can unify it, then like solar is cheap power and all electric construction is cleaner and more efficient. And so if you can get the electrification plus the cheap energy, it's a financial winner with all sorts of crass, unpleasant capitalists. People yeah, they're crass. They're unapologetically money oriented. That's how they got their job. So it's just these people, some of whom seem dead inside, they will put up solar and electrification because it makes money. And I'm focusing on that one personally, on retrofits.
Good point.
Okay, we'll give 1 minute for each presenter for basically closing. Maybe starting with Larry, you want to say final thoughts?
Well, I kind of said it, which is I just think that all of this is incredibly important. I was really excited to see that Living Building Challenge building. I mean, that we need more of those examples all the time. We're still going to need new buildings. There's no doubt about that. But I just feel like we should be putting a whole lot of our focus on how do we fix what we've already got, because it's not just energy and carbon savings we're after. It's fixing our communities. It's fixing our neighborhoods. It's like trying to make what we've already built more livable. So it's not just about energy and carbon. It's about making better spaces for people that are more equitable. So I just think that, you know, I know that all this is important work, and I've just been focused on existing buildings as a way of transforming existing buildings as a way of trying to get to the world we want to have. So.
Justin, final
Thanks,
words.
Larry. Yeah, Larry, you hit it on changing how we approach existing buildings. I think that's really important, and changing our codes to catch up, because you're right, existing buildings are compared to a different baseline, and you can get away with things when you're rehabilitating an existing building. Similar, we need to we really need to drive home the code for all electric buildings on new construction as well. It's for municipalities that have already implemented all electric building mandates. We're still being compared against a natural gas building baseline under Title 24, and so it actually makes it really difficult for an all-electric building to comply without doing some extreme energy conservation measures. Dealing with that now on a project here in the Bay Area. So yeah, I mean, our codes are, the intent is there, we're moving in the right direction, but still codes need to catch up, and we still need to educate our clients.
Sean?
Thanks, everyone.
Yeah, thanks all for the chance to be here. My closing thought, grabbing these crass commercialists by their wallets and getting the retrofits going in existing buildings is totally doable. Just have to align the incentives. And I think that what I was trying to show you in my best practices was this unusually beautiful focus on the community, empowering and taking care of each other. And I hope that also sticks with you, not just the technical part of it. They are technically awesome at the organization of taking care of people in all the ways you might expect, from teaching them banking, English as second language, meals for the kids, getting to zero energy housing, planting the landscaping. It's just beautiful. Justin, that City Hall is gorgeous also. It's just nice to be able to also share Santa Monica style awesomeness with people making 15 grand a year as a family picking olives, which is, or almonds up in that area.
Yeah.
Those two. So it's, I love that. So I'm just going to stick with that one. It was great to be a part of that. I didn't create that. That was a gorgeous organization I just got to be with.
Thank you. Kenny, I'll give it back to you for closing.
Well, I just want to echo my fellow committee member Petra's comment in the chat box that Thank you to all speakers. Really awesome and outstanding project and presentation, and thank you for sharing ideas. It's a lot of great conversation ideas we shared tonight, and I personally learned a lot, and I echo with Sean's comments too. You know, it's not just about the building, it's about the community, it's about the people, and that's why we're doing this. And I want to thank you everyone for joining this event, joining us this evening. And I just want to say thank you. We will be hosting more events next year, and I just want to wish everyone a happy holiday.
Hey,
Yeah.
Thank you, everyone. Happy holidays.
Bye, everyone.
Bye bye.
Bye.
Bye, everyone.